Hi, my name is Sean Sandu, and I'm the project manager of Salient Engineering. We at Salient Engineering were tasked with designing the future Sharp Medical Office Building in Santee, California, off of State Route 52. The parcel chosen for the site is approximately a 5-acre lot that sits at the intersection of Cuyamaca Street and Buena Vista Avenue. The building itself will be 3 stories tall with a total square footage of 86,500. The remainder of the parcel will be for delivery and pickup access, along with patient and employee parking. In addition, the building will feature an urgent care. The components that went into the design consist of geotechnical, traffic, structural, water sewer, and hydrological elements, which led to an estimated total cost of $2.6 million. Just as Sharp has been a committed provider of excellent healthcare, we here at Salient Engineering are committed to providing an excellent design in order to aid in Sharp's mission of expanding healthcare coverage for all people of the San Diego region. We hope you, our clients, find this presentation to be to your liking. Thank you.
Hi, my name is Abraham Fernandez, and I did the grading and site development report for the Sharp Medical Office Building in Santee. The site provided was 5.4 acres, and Sharp requested a building that be 86,500 square feet divided into 3 floors. We decided to make the bottom floor 32,000 square feet and the top 2 floors 27,250 square feet. Sharp also requested that there be 350 parking stalls on site, and we managed to fit 362, 8 of them being handicap and 4 for compact cars. We designed the site to have 2 public entrances, one on Cuyamaca Street and the other on Buena Vista Avenue, and we added an extra entrance on Buena Vista Avenue for commercial vehicles that led straight to the back of the building like Sharp requested. After visiting the site, it was evident that not much demolition was needed. The only demolition needed was the removal of an old asphalt parking lot located on the northeast corner of the site. The grading for the site was fairly simple, since the site was considerably flat. The building was designed on an elevation of 355 feet to reduce fill costs. The total grading and site development cost came out to be $254,661, that including a 10% contingency.
Hi, my name is Laith Awame, and I did the traffic impact report for the Sharp Medical Office Building in Santee. The existing traffic conditions and values were acquired from the City of Santee and from Chen Ryan's circulation update reports. Expected values were determined based on the assumed daily usage and hours of operation for the building, parking lot size of 362 spaces, and assumed driver destination. San Diego codes and manuals were used for this study in the Santee area. This table shows the existing and expected roadway segment level of services side by side. The City of Santee considers a level of service acceptable if it did not drop 2 or more values and or drop below a level of service D. Therefore, all roadway segments within a 1-mile radius of the site are considered acceptable. Only 3 roadway segments shown in bold dropped 1 level of service from a level of service B to a level of service C. This is to be expected as all 3 are classified as collector roads and are within a close proximity of the site. Expected peak hour churning movement counts at Cuyamaca Street and Buena Vista Avenue were used to calculate the level of service in comparison to the existing values. The existing intersection design results in a level of service A, uncongested operations, with consideration to the occupancy and usage of the new Sharp Medical Office Building.
The goal of our stormwater management design was to minimize pollution. We hope to accomplish this by minimizing the volume of water runoff and maximizing the quality of that water. The design was based on a 100-year frequency rain event. Our first solution was to implement a green roof system. We used the California Department of Energy Better Roof Policy as a design aid. Based on a 100-year frequency event, we required a waterproofing membrane with a root barrier to protect the structural deck. This was overlaid with 2 inches of gravel drainage, a layer of filter fabric, and 8 inches of soil with drought-resistant plants. In our 100-year event, the roof would get a peak flow of 1,150 gallons per minute. so we included 12 2-inch by 4-inch downspouts, which can handle 100 gallons per minute each. Our second solution was porous asphalt for our parking lot. We used the Caltrans Porous Pavement Design Guide as an aid. Based on rain expectations and soil infiltration, we designed for 3 inches of porous asphalt, 3 inches of number 57 aggregate as a choker layer, and 1 foot 3 inches of number 2 aggregate as a reservoir. Then filter fabric and subgrade. The site was slightly graded around the southern end toward the parking lot, so any rainfall that didn't evaporate or infiltrate could be stored in that reservoir. Between these two design solutions, we were able to retain all the rainwater on site.
Hello, my name is Tyler McFadden, and I'll be doing the potable and sewer water analysis and design for the San Diego office building located in Santee. To begin, I used this California building minimum required fixture types in order to obtain a 76.5 fixture units and a total demand of 0.0864 million gallons per day. For the potable water design, I used San Diego standards in order to obtain a minimum static pressure of 65 psi and a minimum pressure peak hour drop to 40 psi. The pipe size was developed from taking the longest developed fixture length and subtracting it from the pressure after the meter, which is, we assumed, 55 psi. Hydrant flow and spacing is from California Building Standards codes for fire safety, and we assumed an office building correlated with the square footage. For the wastewater analysis, I assumed an EDU of 30 based on the occupancy and the square footage, occupancy of 400 people, and it generated a 0.014 ADWF from the building's EDUs, and that ADWF was then converted to a peak dry flow rate, which then is used to choose a pipe design for the minimum slope and diameter that would be able to move the peak dry flow rate. We determined that the pipe diameter would best be used as 6-inch, as the flow rate was a little bit below 0.44 CFS.
My name is Jake Marshall, and I did the structural report of the Sharp Medical Office building located in Santee. The purpose of this report was to find the load that would be transferred to the foundation, as well as create a concrete shell for the building. Looking at the components and the self-weights of each component, a dead load of 279 pounds per square foot was found, and looking at the ASCE SEI 7 section for uniformly distributed live loads, 80 pounds per square foot was used. The building will be supported by columns placed every 20 feet, carrying 511 kips each. Here, dimensions for each component of the shell can be found, from the columns, walls, and floor slabs to an alternative beam design that can be used instead of a floor slab. And a plan sheet of a typical component can be found here as well. Here, the reinforcements for each component is seen, as well as the floor slab reinforcement, which contains both reinforcement for the slab itself and the web. Finally, the cost estimate for materials only is found here, and with a 10% contingency, a total cost of $422,554.44 is found. This is just for materials of the structure, none of the work or design work.
Hi, my name is Patrick Luster, and I did the geotechnical investigation for the Sharp Medical Office Building Capstone project. Within my report, I contained recommendations for soil mitigation, development constraints. I included a cost estimate. I looked at the development analysis and geophysical considerations, and I also designed the foundation. As far as the seismic activity in the area, there is a fault that is around 1,500 feet away. Because of this, I decided to use piles for the foundation. Next, I analyzed the CPT data and found that there is sand, clay, and silty sand in the area. I also found and calculated numerous other parameters that are needed for the design of the foundation. In the top left chart, you can see the average data that I calculated from the 4 different CPTs. This data was used for my foundation calculations. My calculations can be seen in the bottom left corner. I came to the conclusion that the piles needed to be 2 feet in diameter and have a length or a depth of 35 feet. They were designed to a safety factor of 2.84. I also decided that we would use cast-in-place piles to limit the installation noise because the project is located in a residential area. I also included a geotechnical cost estimate, which included geotechnical services, general construction costs, the cost of the foundation, and the cost of the parking lot. The parking lot was one of the most expensive parts of this project because we used permeable asphalt to limit runoff. In total, the geotechnical cost estimate with the parking lot was $1,893,832.
Thank you for taking the time to watch our presentation. Salient Engineering is proud to work with Sharp Healthcare, and we hope our design exceptionally met your needs. Thank you.